In computing and optical disc recording technologies, an optical disc is a flat, usually circular disc which encodes binary data in the form of bits and lands on a special material on one of its flat surfaces. The encoding material sits atop a thicker substrate which makes up the bulk of the disk and forms a dust defocusing layer. The encoding pattern follows a continuous, spiral path covering the entire disk surface and extending from the innermost track to the outermost track. The data is stored on the disk with a laser or stamping machine, and can be accessed when the data path is illuminated with a laser diode in an optical disk drive which spins the disk at speeds of about 200 to 4000 rpm or more, depending on the drive type, disk format, and the distance of the read head from the center of the disk. Most optical discs exhibit a characteristic iridescence as a result of the diffraction grating formed by its grooves. This side of the disc contains the actual data and is typically coated with a transparent material, usually lacquer. The reverse side of an optical disc usually has a printed label, sometimes made of paper, but often printed or stamped onto the disc itself. Unlike the 3.5-inch floppy disk, most optical discs do not have an integrated protective casing and are therefore susceptible to data transfer problems due to scratches, fingerprints, and other environmental problems. Optical discs are usually between 7.6 and 30 cm in diameter, with 12 cm being the most common size. A typical disc is about 1.2 mm thick, while the track pitch ranges from 1.6 micrometers to 320 nanometers. An optical disc is designed to support one of three recording types: read-only, recordable, or re-recordable. Write-once optical discs commonly have an organic dye recording layer between the substrate and the reflective layer. Rewritable discs typically contain an alloy recording layer composed of a phase change material, most often again SBTE, an alloy of silver, indium, antimony, and tellurium. Optical discs are most commonly used for storing music, video, or data and programs for personal computers. The Optical Storage Technology Association promotes standardized optical storage formats. Although optical discs are more durable than earlier audio-visual and data storage formats, they are susceptible to environmental and daily use damage. Libraries and archives enact optical media preservation procedures to ensure continued usability in the computer's optical disk drive or corresponding disk player. For computer data backup and physical data transfer, optical disks such as CDs and DVDs are gradually being replaced with faster, smaller solid-state devices, especially the USB flash drive. This trend is expected to continue as USB flash drives continue to increase in capacity and drop in price. Additionally, music purchased or shared over the Internet has significantly reduced the number of audio CDs sold annually. History. An early analog optical disc used for video recording was invented by David Paul Gregg in 1958 and patented in the US in 1961 and 1969. This form of optical disc was a very early form of the DVD. It is of special interest that U.S. Patent 4,893,297, filed 1989, issued 1990, generated royalty income for Pioneer Corporation's DVA until 2007, then encompassing the CD, DVD, and Blu-ray systems. In the early 1960s, the Music Corporation of America bought Gregg's patents and his company, Gauss Electrophysics. American inventor James T. Russell has been credited with inventing the first system to record a digital signal on an optical transparent foil which is lit from behind by a high-power halogen lamp. Russell's patent application was first filed in 1966 and he was granted a patent in 1970. Following litigation, Sony and Philips licensed Russell's patents in the 1980s. Both Gregg's and Russell's disc are floppy media read in transparent mode, which imposed serious drawbacks. In the Netherlands in 1969, Philips research physicist Peter Kramer invented an optical video disc in reflective mode with a protective layer read by a focus laser beam. U.S. Patent 5,068,846, filed 1972, issued 1991. Kramer's physical format is used in all optical discs. In 1975, Philips and MCA began to work together, and in 1978, commercially much too late, they presented their long-awaited Laserdisc in Atlanta. MCA delivered the discs and Philips the players. However, the presentation was a commercial failure, and the cooperation ended. In Japan and the US, Pioneer succeeded with the video disc until the advent of the DVD. In 1979, Philips and Sony, in consortium, successfully developed the audio compact disc. In the mid-1990s, a consortium of manufacturers developed the second generation of the optical disc, the DVD. Magnetic discs found limited applications in storing the data in larger amount, so there was the need of finding some more data storing techniques. As a result, it was found that by using optical means large data storing devices can be made, which in turn gave rise to the optical discs. The very first application of this kind was the compact disc, which was used in audio systems. Sony and Philips developed the first generation of the CDs in the mid-1980s with the complete specifications for these devices. With the help of this kind of technology, the possibility of representing the analog signal into digital signal was exploited to great level. For this purpose, the 16-bit samples of the analog signal were taken at the rate of 44,100 samples per second. This sample rate was based on the Nyquist rate of 40,000 samples per second required to capture the audible frequency range to 20 kHz without aliasing, with an additional tolerance to allow the use of less than perfect analog audio pre-filters to remove any higher frequencies. The first version of the standard allowed up to 75 minutes of music, which required 650 megabytes of storage. The third generation optical disc was developed in 2000 to 2006, and was introduced as Blu-ray disc. First movies on Blu-ray discs were released in June 2006. Blu-ray eventually prevailed in a high-definition optical disc format war over a competing format, the HD DVD. A standard Blu-ray disc can hold about 25 GB of data, a DVD about 4.7 GB, and a CD about 700 MB. First generation. Initially, optical discs were used to store music and computer software. The Laserdisc format stored analog video signals for the distribution of home video, but commercially lost to the VHS videocassette format, due mainly to its high cost and non-re-recordability. Other first-generation disc formats were designed only to store digital data and were not initially capable of use as a digital video medium. Most first-generation disc devices had an infrared laser reading head. The minimum size of the laser spot is proportional to the wavelength of the laser, so wavelength is a limiting factor upon the amount of information that can be stored in a given physical area on the disc. The infrared range is beyond the long wavelength end of the visible light spectrum, so it supports less density than shorter wavelength visible light. One example of high-density data storage capacity, achieved with an infrared laser, is 700 megabytes of net user data for a 12 cm compact disc. Other factors that affect data storage density include the existence of multiple layers of data on the disk, the method of rotation, constant angular velocity, or zoned cav, the composition of lands and pits, and how much margin is unused is at the center and the edge of the disk. Compact disc and derivatives: video CD, super video CD, laserdisc, GD-ROM, phase change dual, double density compact disc, magneto-optical disc, minidisc. Second generation optical discs were for storing great amounts of data, including broadcast quality digital video. Such discs usually are read with a visible light laser. The shorter wavelength and greater numerical aperture allow a narrower light beam, permitting smaller pits and lands in the disc. In the DVD format, this allows 4.7 GB storage on a standard 12 cm, single-sided, single-layer disc. Alternatively, smaller media, such as the data play format, can have capacity comparable to that of the larger, standard compact 12 cm disc. DVD and derivatives: DVD audio dual disc, digital video express, Nintendo GameCube game disc, Wii optical disc, Super Audio CD, enhanced versatile disc, data play, universal media disc, ultra density optical. Third generation optical discs are in development, meant for distributing high-definition video and support greater data storage capacities, accomplished with short wavelength visible light lasers and greater numerical apertures. Blu-ray disc and HD DVD uses blue-violet lasers and focusing optics of greater aperture, for use with discs with smaller pits and lands, thereby greater data storage capacity per layer. In practice, the effective multimedia presentation capacity is improved with enhanced video data compression codecs such as H.264, MPEG-4 AVC and VC1. Blu-ray disc, Wii U optical disc, HD DVD, CBHD, HD VMD, digital multi-layer disc, fluorescent multi-layer disc, forward versatile disc. Fourth generation. The following formats go beyond the current third-generation discs and have the potential to hold more than 1 terabyte of data. Archival disc, holographic versatile disc, LSR, protein-coated disc. Overview of optical types, notes, prototypes and theoretical values. Years from start of development till end of sales or development. Recordable and writable optical discs. There are numerous formats of optical direct-to-disc recording devices on the market, all of which are based on using a laser to change the reflectivity of the digital recording medium in order to duplicate the effects of the pits and lands created when a commercial optical disc is pressed. Formats such as CDR and DVD-R write once, read many, while CDR-W and DVD-RW are rewritable, more like a magnetic recording hard disk drive. Media technologies vary. M-Disc uses a different recording technique and media versus DVD-R and BDR. Specifications.